Okay, so as you can see, we have our maths test here, and we are going to complete the corrections now in relation to the maths test. So we'll start with part 1 of question 1, where we're asked to simplify the following surds. So here we have the fifth root of a to the power of 3 times a to the power of 7. So, well, simply, I have two powers, two things of the same base being multiplied by each other. So all I do is I add the powers. So adding a to the power of 3 times a to the power of 7 gives me a to the power of 10. And I want to get the fifth root of that. So rewriting that, I can say, well, that's a to the power of 10 over 5. Why? Because, again, I remember my rule from my log tables, which says a to the power of p over q is equal to the qth root of a to the power of p. Okay, and so simplifying that, a to the power of 10 over 5 is the same as a to the power of 2. And just put a red box around that there to show that that's our answer. Now, equally here, I could have said that's the same as, I could say the fifth root, and I'll just do it in a different colour over here, I'll do it in green. I could have said that's a to the power of 10 and to the power of 1/5, because I know that also, and then multiplying that out gives me a to the power of 10 over 5. So equally, whichever way I go here is going to give me the same answer as a to the power of 2. Okay, and we will go on now and have a look at question 2. Okay, so as you can see here, we're asked to simplify the following surds, and in order to do that, I'm going to just begin by writing over here on the corner of my page the square numbers. So I've got 1, 4, 9, 16, 25, 36, 49, and 64, and that will do me for the moment. Okay, so now I want to see, well, what can I, do I see anything that's going to be in common with these? Now, I do know 5 is a common multiple, definitely here, but obviously this ends in 0, so 5 also goes into this. So dividing 5 in, that's going to give me the square root of 5 times the square root of 16 plus the square root of 5 times the square root of 49, and here plus the square root of 5 times the square root of 81. Now, and looking over, so I should have put 81 down here onto this list and down to 100. Okay, so looking over here at my list, well, then I can see 16 is a square number, so I've got 4 root 5. I also have, as another square number, here's 49, so I have 7 root 5 here, and my plus, and here I have also got 81, so I have 9 root 5. And so adding 4 plus 7 is 11, plus 9, that gives me 20 root 5. Okay, and on to our next question. Okay, so as you can see here, I have two surds and they're divided by a surd. So in order to simplify that, I need to multiply top and bottom by the conjugate of the bottom. Okay, and so doing that, I'm going to have along the top 2 root 2 plus root 3, bracket, root 2, and the conjugate of the bottom, I change the sign here in the middle so that minus becomes a plus, root 3, over root 2 minus root 3 multiplied by root 2 plus root 3. And again, we can see I'm multiplying top and bottom by the same thing, so I haven't changed the value, it's the same as multiplying by 1. Okay, and on we go. And I've just omitted here that square root sign, so just putting that in. Okay, so off we go. So I know here when I'm multiplying, it's the first by the first, and the first by the second by the first, and the second by the second. So off we go, writing that down. So 2 root 2 times root 2 is 2 root 4. 2 root 2 times root 3, from here to here, the first by the second, is 2 root 6. Here I have root 3 times root 2, which gives me root 6. And here in the last bit, root 3 times root 3 gives me plus root 9. Okay, and similarly on the bottom, I have the first by the first, root 2 times root 2, plus root 2 times root 3. In fact, let's go do that in a different colour. So the first by the first, root 2 times root 2, plus root 2 times root 3. Second by the first, and the second by the second. So first of all, root 2 times root 2 is root 4. Root 2 times plus root 3 is plus root 6. Here, very happy, I've minus by a plus, which gives me minus root 3 times root 2 is minus root 6. And again, minus by a plus is minus root 3 times root 3 is root 9. Now, having a look here, I'm delighted because I can cancel out these two central surds. So that's plus root 6 and minus root 6 gone. And now I just need to tidy up a little bit here. So I've up on top, I have my 2 root 4, well that's 2, and square root of 4 I know is 2, plus 2 root 6 plus root 6 is plus 3 root 6, I can't do anything else with that, plus the square root of 9 is plus 3. And down on the bottom I have the square root of 4 is 2, and the square root of 9 is 3. And so very close to finishing now. We just have equals, go over here, equals, so 2 by 2 is 4, plus 3 root 6, plus 3, all over 2 minus 3 is minus 1. So that's 4 plus 3, just tidying it up, 7 plus 3 root 6 divided by minus 1, which either gives me minus 7 plus 3 root 6, or I can write it as minus 7 minus 3 root 6. Either or is a perfect answer. Okay, so make sure you have all of these copied into your copy in the exact same way that I have done them here. Go back over them, see is there anything that you don't understand. Replay that section of the video if you need, and then let's move on to question 2. Okay, so here in question 2, we're asked to solve for x, where 2 to the power of 2x plus 1 is equal to 128 over the square root of 2. So changing each of those to the powers of 2, I am going to say, well, that's 2 to the power of 2x plus 1 is equal to, well, 128 is 2 to the power of 7. And the square root of 2 is 2 to the power of a half. Okay, here then on our, keeping this the exact same here, I have 2 to the power of 2x plus 1 is equal to 2 to the power of 7 minus a half. And again, I have here 2 to the power of 2x plus 1 is equal to 2 to the power of 6 and a half, or keeping it all as one fraction, 13 over 2. Now I can easily just cross out the two bases here because I have just one term on either side. Okay, and now that I've just the one term, that lets me move on to the next step here, where all I'm doing is simplifying again. So here I have 2x plus 1, the top of my index, is equal to 13 over 2. Okay, so taking away the minus 1 from each side, and remember that's the whole number, that's going to give me 2x is equal to 11 over 2, because that's the same as, if we remember, that's 1 is the same as 2 over 2, isn't it? Okay, and so then just to finish off, divide here by 2, divide here by 2, that gives me then that x is equal to 11 over 4. Always leave these in fraction form unless directed otherwise. Okay, and so that's our answer to question 2. Okay, and here we are with question 3, so we're into our log questions now. And we're told here, given that log 2 to base a is equal to p, and log 3 to base a is equal to q, write each of the following in terms of p and q. Okay, so here I've log a of 8 over 3. So the first thing I know I can do there is to separate that into log to base a of 8 minus log to base a of 3, and that's from my laws of logs. Now I look at this and I can see that matches up here already. I can put my q in there if I want. So that's q written in. But this is 8, whereas I want it in with a 2. So what do I know? Well, 8 is 2 to the power of 3. So just writing that down here, I've log to base a 2 to the power of 3 minus my q from up above, and then shorthanding that again, I can bring the power down as the coefficient of the log. So that gives me 3 log to base a 2 minus q, and so now I have exactly what is written up here. So that gives me 3 times, and instead of log a of 2 I have p, so I have 3p minus q when that is simplified. So again, a box around my answer. Okay, and we'll move on to the next question. But again, just remembering that all I've done here is used my laws of logs as they're given in the log tables. Nothing new. Okay, and so here we go with part 2 of the question. And this time we are asked to simplify log a to base a 9a squared over 16. So again, using my laws of logs, I know the first thing I can do is rewrite that as log to base a 9a squared minus log to base a of 16. Again, I know I want something similar to the last question with 2 in it, and I know 16 is the same as 2 to the power of 4. So that's the first thing that strikes me here. I've logged base a 2 to the power of 4. Here I want to be able to break this up a little bit, and so I need to deal with the 9a squared first. So I know well that 9a squared is the same as 3a all to be squared. So that's going to give me over here log of 3a all to be squared. And so bringing down those coefficients, those powers as coefficients, that's going to give me 2 log 3a minus 4 log to base a of 2. Now here I still haven't matched this with this, but I can see the 3 and the 3. So I know I want 3 on its own. Again, I know my rules of logs, that's the same if I have 2 logs multiplied together. So here I'm going to say that's 2 log 3 plus log a. And sorry, they were to base a. So I should have base a in all of those. So there's base a, and a. Minus 4, and instead of log a to base a of 2, I can write in p. Now, so over here at my bracket, I have 2. Instead of log base a of 3, I can write in q plus, well, log a to base a I know is 1 from my basic rules. So that's 2 bracket q plus 1 minus 4p. And so just really, I suppose, simplifying that out, we're just going to say, well, that's equal to 2q plus 2 minus 4p. And now I could again take out the 2 altogether and factorize, but I can just leave it as it is. They haven't specified any further than that. So that's a perfect answer there. So again, all we've used here is our laws of logs. So the first law of logs, to separate up here, I have 2 things divided by each other, so the laws of logs say that they're subtracted. Here I have 2 things multiplied by each other, So again, the laws of logs say, well, that's addition. Okay, and again, our usual one that we've used lots of times, our powers become coefficients. Okay, and so there we go. Okay, and here we go with part B, and it says, given that P is equal to log x to base C, express this statement here in terms of P. Okay, well, so what can I do here? I'm going to rewrite, well, I know first of all, log, or the square root of x, I know is x to the power of a half. So that's going to give me log to base C, x to the power of a half, plus log to base C of C of x. Okay, I can bring down my power here as a coefficient, so that's half log to base C of x, plus, what can I do here? Again, I have two things multiplied together, so the laws of logs tell me that that's the same as log C to base C plus log x to base C. Splitting it up in that way. Now I can see, well, what have I got here that I can simplify? So here I have a half, and I was told in the question P is equal to log C of x. So I have a half P. Over here I have a P as well, plus P. And this bit here in the middle, log C of C, well, I know that that is equal to 1. So I have a half P plus 1 plus P. So simplifying that, tidying it up, well, a half and 1 is 1.5. So that's 1p and a half, or that's the same as 3p over 2 and plus 1. And that's our answer there. So again, red box around our answer, and we're finished. Again, make sure that you have this taken down, that you understand every bit, that log anything to the same base as itself is always 1. And here, obviously, all we've done, our power became the coefficient. And this other law of log, where two things multiplied together, we can use the law of log of addition. Our final question is a lovely question, a mixture of functions, a little bit of logs in it, a little bit of indices, and just a little bit of thought and common sense. So very important to read the question. So here it says, sometimes it's possible to predict the future population city using a function, and here we're given the function here. The population of Avalon, another city, we're given the function here. But here in the first, and then very important, before we get to there, it says, in the functions above, t is time in years, and t equal to 0 is the beginning of 2010. So that's really important for us. So both s and k are constants, and we're asked to find the value of s if the population of Sapphire City at the beginning of 2010 is 1.1 million people. And we're told just above it that t equal to 0 is the beginning of 2010. So that's the first thing I'm writing down here. I've t equal to 0, and I'm using Sapphire City, so it's p of t is equal to, or this time it's going to be p of 0 is equal to s e to the power of 0.1 to the multiplied, instead of t, it's by 0, and that's multiplied by 10 to the power of 6. And p of 0, instead of that, I know that that is equal to 1.1 billion. So I'm just going to write that in there. So I have my 100,000, 000. Okay, and so that's all the information given from us in the question. So here, just to make things a little bit easier, I am going to divide across here by 10 to the power of 6 to get rid of that. So here I'm going to divide by 10 to the power of 6. So that's going to cancel that here. And 1.1 million divided by 10 to the power of 6 leaves me with 1.1. Here is equal to s e to the power of, well, 0.1 times 0 is 0. And I know that anything to the power of 0 is equal to 1. So here I'm going to have that's 1.1 is equal to s bracket, well, e to the power of 0 is 1. So that just gives me an answer of s is equal to 1.1. Okay, and we're going to take that answer with us for the next part. And even just helpful at this stage to rewrite our function now with s solved. So I know my function now is p of t is equal to 1.1 e to the power of 0.1 t times 10 to the power of 6. And I can take that statement with me into part B of this question. So again, before we move on, just, make sure we've this taken down as it is. But again, remembering, really that question wasn't too difficult if we read the question properly and we're able to substitute in t equal to 0 for t, and that we had our what we were given here, 1.1 million, equal to that function. Okay, and off we go with part B. So in part B, here we go, part B, we're asked to find the predicted population in Sapphire City at the beginning of 2015. So just copying down, this was our function that we have here from the last question. And in the last question we were told that t equal to 0 is the beginning of 2010, which means for me in this question, well, I'll just be letting t equal to 5 to represent the beginning of 2015. So here I'm going to just find p of 5. So that's going to be equal to 1.1 e to the power of 0.1. And instead of t, I'm multiplying it by 5. And that's all multiplied by 10 to the power of 6. And putting that into my calculator, I get an answer of 1813. 593.38. Now obviously I can't have 0.38 of a person, so I'm going to round down, and that's going to give me an answer equal to 1,813,593 people. So that's at the beginning of 2015. Now in the next question, I am asked to find the population change. I'll just move that red box. To find the predicted change in the population in Sapphire City during 2015. Well, I know the end of 2015 is really the same as the beginning of 2016. So this time I'm going to use t equal to 6. And if I know the population at the beginning of 2016, then I can subtract them and the difference gives me the change. So substituting that into my formula, I have for 2016, 1.1 e to the power of 0.1 times 6 multiplied by 10 to the power of 6, which gives me a population of 330 people. Again, rounding down because we can't have points of people. So to find the difference, well, the difference is going to be equal to, or the change is equal to that 2,004, 2,004,330 minus our answer from the beginning of 2015, 1,813,593, and so that gives us a predicted change in 2015 of 190,737 people. Okay, so here in this question in part D, we're asked the predicted population in Avalon at this year at the beginning of 2011. So that's important for me. That means I know straight away that T is going to be equal to 1 here. So T equals 1. for 2011, and it's 3.709795 million people. And then we're asked write down and solve an equation in K. So I know I need to go back and get my function for Avalon. And I know that my function for Avalon from the question on the previous page told me that Q of T is equal to 3.9 e to the power of kt, and again multiplied by 10 to the power of 6. Okay, and so I have t equal to 1. I know what it's all equal to. It's equal to this 3709795. So I need to show that k is equal to minus 0.05. So off we go. So that implies here that 3709795 is equal to 3.9 e to the power of k times 1, which is just k, by 10 to the power of 6. Now, just to make things easier for myself, I am going to divide across by 10 to the power of 6. And so here I'll divide by 10 to the power of 6. And that means that this bit here will cancel. So now the next thing that I want to get rid of, well, just rewriting that gives me 3709795 over 10 to the power of 6 is equal to 3.9 e to the power of k. Okay, and so dividing here by 3.9 will get rid of the 3.9 on this side. So I'm also dividing here by 3.9. So these have cancelled, and I can see then I have e to the power of k is equal to 3,709795 over 3.9 by 10 to the power of 6 is equal to e to the power of k. And again, changing now from index form into log form means I'll be able to find k. So remembering, as we always have, just to rewrite an example. So if we have 2 to the power of 3 equal to 8, in fact, let me do all of those in different colours to demonstrate first. 2 to the power of 3 is equal to 8. Well, then I know that's going to be log. The same base is 2 of the number 8 is equal to 3. So here, what have I got? I'm going to have log to base e of 3.3709,795 over 3.9 by 10 to the power of 6, just putting brackets around them, is equal to k. And when I put all of that like that into my calculator, I get k is equal to minus 0.04999. And so rounding it off to 2 decimal places, that tells me k is equal to minus 0.05, which we were asked to show. And so we're just putting a red box around our answer. Okay, so we have a function for, we can rewrite our function for q of t in the same way that we did in the last question. And I can now say that that is q of t is equal to 3.9 e to the power of minus 0.05 t by 10 to the power of 6. Okay, and I'll take that with me for this next question. Okay, and so here in the final question, we're asked to find the year during which the populations in both cities will be equal. So taking both functions now, all I need to do is put them equal to each other. So here I'm going to have 1.1 e to the power of 0.1 t by 10 to the power of 6 is equal to 3.9 e to the power of minus 0.05 t by 10 to the power of 6. Now I'm going to divide across here by 10 to the power of 6. So I'll also divide here by 10 to the power of 6, and it just tidies those up and gets rid of those for me nice and easily. Okay, so the next thing I might divide here by is I'll divide by 3.9 to tidy up this side. So if I divide there by 3.9, I'm also dividing here by 3.9. So those 3.9s have cancelled here. And on my left hand side of the equals, I'm left with 1.1 e to the power of 0.1 t divided by 3.9. And that is equal to e to the power of minus 0.05 t. I just really want to bring my e's together. So here I'm going to divide across by e to the power of 0.1 t, which means I'll also divide on this side of the equals by e to the power of 0.1 t. And so those two cancel, and I'm left very neatly. So on this side I'm left with 1.1 over 3.9 is equal to e to the power of minus 0.05 t over e to the power of 0.1 t. So here, what have I got? Two things of the same base divided by each other. So I know I just have to subtract the powers. So that's going to give me e to the power of minus 0.5 t take away 0.1 t gives me e to the power of minus 0.15 t. And so I can use my logs to solve for t, or to get 0.15 t on its own. So I know here that that's going to give me log to base e of 1.1 over 3.9 is equal to the power, and in this case the power is minus 0.15 t. And so putting that into my calculator, that gives me an answer of minus 1.265666, so on, is equal to minus 0.15 t. And so dividing here by minus 0.15, I also divide here by minus 0.15. These have cancelled, which just gives me t on the right hand side. And here divided by minus 0.15 gives me an answer of t equal to 8.43 years. And we're asked to find the year during which. So when does it happen? During t equal to 8.43, or at t equal to 8.43, which means it happens during 2018, t equal to 8. And so that is our answer there. Okay, so there we go. That's the end of the test corrections and solutions. So make sure they're all in your copy, and go back over them to see do you understand them. If there's any point, just replay that section of the video and write it out. Just go over it again to see can you make sense. Okay.